In this video, I'm going to talk about frequency and pitch. You don't need to follow along or worry about all this setup for now. I know it may look a bit confusing, but later in this course, we will go through everything in detail. So here I have 4 tone generators called oscillators. In this setup, each of them generates a waveform called a sine wave. Each oscillator is currently set at frequency of 440 Hz. What does this mean? It tells each of the sine waves to complete 440 cycles per second. This is frequency. And what is a cycle? A cycle is basically the time between the positive half, the negative half, and back to zero. So 440 Hz means 440 of these cycles per second. Now let's see what happens if we change the frequencies of these oscillators. And this one will be 220, half of the 440. This one a 110, half of the 220, and 55 again, half of the 110. So I'm telling these to complete fewer cycles per second. Here I have something called an oscilloscope, which shows us the waveforms as voltage versus time relation. You can see the 55 Hz, which is the lowest frequency we have here, is kind of the widest wave. This is the slowest here. Then we have the 110 Hz green sine wave, which oscillates 110 cycles per second, and double the blue one. Moving up, we have 220 Hz, again, more condensed, twice the number of cycles of the green one. And finally, the frequency of 440 Hz or 440 cycles per second. Okay, so now you may wonder, what does this mean in terms of sound? If you're a musician, you may already know the frequency of 440 Hz relates to the pitch of A4. 220 is A3, 110 is A2, and 55 is A1. If you're not a musician, don't worry, let's just listen to how this sounds. I'm going to play the red sine wave, which is 440 Hz. What you can hear is called a pitch, and this is how we perceive the frequency of 440 Hz in terms of whether it sounds low or high. Let's compare it to the 220, which sounds lower. And 110, which is lower again. And our lowest sounding frequency here is 55 Hz, a low bassy drone sound. So you see, the lower the number of cycles, the lower the sound. And more cycles per second means a higher pitch. Now, if I increase the volume of these channels, you may notice the relationship between these frequencies sounds pleasant. It's like they sound good together. This is because they are each an octave apart. If you're new to music theory, just remember that notes that are an octave apart sound similar to each other, but one is higher in pitch than the other. And when you move up one octave, you double the frequency, resulting in a sound wave with twice as many cycles per second. So moving down one octave halves the frequency, resulting in a sound wave with half as many cycles per second. You don't need to know the pitch to Hertz conversion for each note. There are ways to automatically tune oscillators. So the key takeaway is that the frequency is the number of sound wave cycles that occur per second, measured in Hertz. And pitch is how we hear the sound subjectively based on its vibrations in terms of how low or high it is.